Hi everyone. So today we are here with a new problem, and the problem is what is the problem? The problem is deepest leaf sum. It is 1302 medium type of problem, and we see what is the problem and then try to solve it. So in this problem we have a given a root of a binary tree, and we have to return sum of values of its deepest leaves. What do you mean by this? Let's take an example. You can see this is a binary tree. So deepest leaves means, as you can see, this 5 is a leaf, this 7 is a leaf, this 8 is a leaf. But this 7 and this 8 is a deepest leaf which lie in more depth. And for all that deepest leaf we have to add it and return it. So here the answer is 15, right? Similarly, we have given a binary tree and we have to solve this. Okay, so you can try this by your own, and if you're not able to solve it, I am here. Okay, so very first approach, you can see here that deepest leaves also means, if we talk about the level order. Okay, if we talk about the level order, so whatever the node which is present at the last level, so you can see the deepest leaf should lie in the last level. So what we can do, we can go through each level. Okay, and what we can do, we can find the levels, the maximum depth. So first of all, what we can do, we can find the maximum depth of this tree. How we can find? We can basically call the left subtree to return its left left deepest depth, and also call the right subtree to get its right most deepest depth. Okay, and from the left and right, the maximum depth, what we have, we can take it and add one, and that's how we are getting the maximum depth of the binary tree. So it is just a recursion. I think you know how we can find the maximum depth. So the simple thing, we call the left subtree and right subtree and ask for the maximum depth for the left and right subtree. Whatever the maximum of both, we take it and add one, that is the depth of this whole subtree. So in that case, you can see 1, 2, 3 and 4. So the maximum depth is 4. And what we can do, we can go through all these depths. This is level 1, this is level 2, this is level 3, this is level 4. And when we reach, whenever level reach to the maximum depth, in that whatever the nodes which is present in that level, we can simply add it in a queue or array and then add it and return it, right? Now this is a very simple approach, and here the we talk about the space complexity, right? Because the time complexity is simple, we are going through each node, but space complexity, we are using an extra array to store these things. Now the thing is, can we solve it without using the extra space? So answer is yes. How we can do this? Let's see. We are using the same thing, which is maximum depth concept, but what we do, we are not using an extra array to solve it. So the maximum depth is 4, right? Let me rub it. Great. Now what we do, we basically, let's suppose at this point we know the maximum depth is 4. Now we will go for each left subtree and right subtree, and we will see until our maximum depth is equal to 1. Let's see. So now you can see the maximum depth is 4, so we can call to the left subtree, and the maximum depth is 3 because one level is down. Now we can go left and one more level is down. Now we can go left, now one more level is down. Now you can see when our depth is equal to 1, it means we are at the last deepest node. In that case, we take one variable which is sum and add the node value in it, which is 7. Initially it is 0, then 0 plus 7 is 7. Now we come back. In that case, the level is 2 and it is not equal to 1, so we don't do anything. Here we can call, here the depth is 2, so we don't do anything. Now we call to the right side, the depth is 3, we don't do anything. The depth is 2, we can't do anything. Now the depth is 1, and in case of 1, we can simply take it and add it, and now the answer is 14. And when, sorry, not 14, it is 15. And when we come out of this sum is 15, and we can simply return this sum, and that's how we can solve it. Let's see the code and we can understand from it.
हो गया
So now you can see the code. So what we do, we basically first check here if our root is none. In that case, we simply return 0. Other than that, we are finding the maximum depth. How? Simple code. Our if root is none, we can return 0. It means there is no root. It means there is no such level. Otherwise, we can call to the left side, we can call to the right side, we can call get the left depth, right depth, whatever the maximum from these two, we can take it and add 1, and that's how we are getting the maximum depth. Now this maximum depth is passed to another function which is getSum, right? So I am using a constructor here and this variable is there. So what I do, simple as that, in the getSum we basically do the same thing. We call to the left part and right part, and in that when we call to the left and right part, we will decrement our maximum depth by 1, as you can see here. And at every position we will check if our maximum depth is 1. In that case, whatever the root value is there, we can simply add it, and that is how the sum of all the deepest leaves is stored in the answer, and at the end we can simply return it. I hope you like this problem, you can understand how we can solve it, and you can also understand the concept of maximum depth. So thank you.